Good morning, y'all. Today we have Bryan Brazelton. He's the specialty products professional for Contech Engineer Solutions. He's been presenting us today. Buzz joined Contech in 2009. He's a graduate from the University of Oklahoma with a liberal studies degree. Buzz is responsible for driving technical marketing, promotion, and sales for tunnel liner plate, which is what he'll be speaking on today. Metric sheathing, collector pan, and bridge plank, as well as providing technical knowledge and consultative solution developments to engineers, municipalities, water divisions, and contractors. Outside of Contech, Buzz has a wife, Sarah, and two sons, Brady, 13, and Caleb, 11. So passing on to Buzz.
Thank you very much, Carlos. I appreciate it. Well, thank you all so much. I really appreciate the opportunity to speak to you today. We're going to talk a little bit about tunnel liner plate. I always just like to ask, does anyone, I know there's a few in here, so you're not allowed to answer, but other than that, anybody else know anything about tunnel liner plate? No? Okay. Hey, I like it. Mold, mine's I can mold, you know? But today we're going to talk about technical use of two-flange tunnel liner plate, talk about how it's installed, vertical shaft applications, relining, grouting, and if y'all have any questions, we're going to answer those as well. So Contech Engineered Solutions, if you're not familiar with us, we are a full site solution civil construction product company. We sell everything from precast bridges to pedestrian bridges, stormwater units, underground detention, corrugated metal pipe, a lot of different things. And I like to show this little slide up here and say, if you run into a project that looks like this, you call me first. I get all the credit. It just makes me a little happier. So Contech, we want to be your project partner. Bridges, structures, everything I talked about. We have 60 engineers and CAD specialists at our Westchester, Ohio facility, 200 of me running around the country, and 100 years of experience in the construction industry. So this is just a map of kind of all the places that we have across the country. Everything with tunnel liner plate is all made in Winchester, Kentucky. So this is right here. So it's about a 2-day delivery to get down here to Texas. But as you can see, we have a large amount of plants here in Texas. All these are corrugated metal pipe plants. And one of them is actually, we make our own precast bridges in outside of Houston. So this one here has kind of the same things that I said before, but really what I want to show here is the 3 arrows: solution development, design assistance, installation. Call me, you're running into a problem, you need some questions, some help with measuring some liner plate, help you out with solution development, design assistance, including calculations that you can look at that are unsigned, not signed calculations to help with your project, and then installation. I'm the only one in the state of Texas that actually does this job, so I will be on site when it delivers to the job site as well. So let's get to the star of the show. Tunnel liner plate. So, two-flange tunnel liner plate is a great way to accomplish tunnel lining support for utility, conduit, sanitary or storm sewers, culverts, underpasses, mine access, vertical access for horizontal tunneling. So how you go horizontal, you got to get there vertically, right? Construction of foundation shafts we even do, and then relines of failing structures. All right, so there's 2 types of liner plate. There's 2-flange and 4-flange. I like to just ask this just to make sure that you guys get full grasp of it. Can y'all tell me the difference between 2-flange and 4-flange? 2 flanges. So that would mean 4 flanges. What? 4 flanges. I mean, it's so simple, it's difficult, right? Well, 2-flange tunnel liner plate comes with a fully continuous corrugation, overlapping longitudinal seams, and this helps result in a stronger structure. So as you can see, it's my little thing that we get to look at, right? This is what a piece of 2-flange tunnel liner plate looks like. Every plate is 18 inches wide. So we got the fully continuous ring. Each one would be connected to another ring. So you got a fully continuous ring. You got these overlapping seams here that are then bolted in. That actually gives a stronger seam strength, up to 30% stronger than our competitors. It's not just me saying it. ASCE actually says that when it comes to seam stiffness factor, 2 flange is at 50, while 4 flange is at 111. What does that mean? Real world terms, talking like a 12 gauge, they have to be 8 gauge. So it's about a 2 gauge difference. So the other thing with 2-flange tunnel liner plate, like I said, we have the fully continuous corrugations. We got the 2 flanges on the side. Four flange has four flanges, obviously, that go all the way around the plate. So when they're bolted together right here with the flanges, with the bolts in the middle, right? So if you get some downward thrust, you can get a slight hinging effect on the plate, which means the plate will bend down, and you're hoping that these bolts right here will keep it in place. With our corrugations and our overlapping seams, which we see right here that come together, if we get some downward thrust, actually get a compaction effect. So it actually helps make that stronger, the plate will not bend. Are there any questions about that? Should have come over here. All right, so gauging tunnel liner plate. Like, not a lot of information is actually really needed to get a good gauge for this. So we will take the diameter of the tunnel liner plate. So this is a 120-inch tunnel liner plate, 124, I believe. The height of cover, so 18 feet, we say here. We put in H20, HS25, E80, basically whatever you're needing. So if you need rail loading, you got E80. And then soil friction angle of 0. Now, we are a very conservative engineering company. We like to go with our horizontal tunnels being 0, just because we want to assume that it's the absolute worst conditions that we have. So we're not playing with it. Maybe if we put it to 15 or 30 and the ground's even worse, there could be some issues. We just like to go with a straight 0, be very conservative on what we're doing. And here we put in 10 gauge, 0.135. As you can see, seam strength, seam stiffness, and buckling all required at 3, 2, and 2, and this checks at 10 gauge. So this is just kind of an example of what we do on each project that we have going on. So when I get a project that comes out, I actually check every run. So to make sure that they all match up with this. So if you have 25 runs, I put in a high cover over each run just to make sure this all works out. So much like I showed you that big picture that we have, all the different stuff that Contech has, right? We love to have options. We want to have anything that we can have for you. Same thing is true with tunnel liner plate. We have arch, horseshoe, pipe arch, underpass. We even recently started to do an oval liner plate structure that we do for vertical shafts. And we do that in a lot of places that maybe have a very small footprint that you can put it in. So if you have a house here, and you have a road here, and you have a very small area that you can put it in, but you still need, say, a 25-foot shaft, we can make it a little oval so that you can have that extra space to work out of the tunnel, but it won't interfere with anything that you may have on either side. So as well as shape flexibility, we like to have size flexibility. We do that by going by 2 inches, 48, 50, 52, 54, 56, all the way up to 50 foot. We can do all of those. Material finishes as well. This right here, my lovely piece of steel, is aluminum. We do just plain black steel, dip galvanized, which we dip in our Winchester, Kentucky plant, and then even asphalt coat. Goes without saying, a lot of contractors are not huge fans of asphalt coating, but some places like the city of Irving still require it, so we still do that. Any questions on any of that? So I sort of lied to you, but I kind of didn't. I said we go to 2 inches, 2-inch increment diameters, right? Well, all of our liner plate is done on a neutral axis diameter, which means we found a spot right here in the middle of the flange. It goes about right this area, right here across a bit. We call that 48 inches. A lot of people, casing, some other types of products that you use go by ID. So I'd like to point out that 48-inch NAD tunnel liner plate has an ID of 45. So 50, 47 it's minus 2.34 inches. So you call me up and say, hey, Buzz, I need some 54-inch liner plate. First question to you is going to be, is that ID or NAD? Right. So I'd just like to show this so that you, when I say, oh, okay, well, that's going to be 57.25 ID, you're not like, what are you talking about? But that's what we do for our ID. Our OD, you add another inch and a 1 3/4 inches as well, if you're looking for OD. So we just have those options right there. So 18-inch roll. I didn't talk about it much before, but I'm going to talk about it now. This is a hand mining product. So it's exactly what you're thinking about. People are in the mine or in the tunnel, they're actually digging it out using hammers, shovels, and things like that, right? So we're digging it out. When they put in the liner plate and we have FRP or whatever we're gonna put in there, maybe cast iron, something like that, because this is for going underneath roads, protect those roads and protect that FRP or water or whatever we have running through the middle of it. We've kind of come up with something that we call the 18-inch rule. And I've done this with contractors through the years just to kind of work on this idea, which is asking for 18 inches from the OD of the belt of the carrier pipe to the ID of the tunnel liner plate. So I know it's early. It's 11:15. We've only had 3 cups of coffee today, right? But we're going to do a little bit of math. So FRP, we're going to use FRP in this scenario, 28-inch FRP. The belt OD is 31 inches. So you're calling me up to say, hey, I want some liner plate. What size are we going to use? 31 inches plus 18. 31 plus 18.
49.
49 and a quarter. There we go. See, I just like to get y'all involved, you know? So it'd be 49 inches. So the closest thing that we would do that would be a 52-inch NAD with a 49 and a quarter pipe. Does that make sense? Is there any questions? Have I lost you, confused you yet? So as I said, this is a hand mining application. So this is kind of what the face would look like right here as they're digging out the tunnels as they're going along. They put a rail in each tunnel that actually pulls out the spoil. The rail is actually laser measured so that it's completely on grade. But part of with that rail and with the digging out that you're going to run into and the 18-inch rule, which makes that so important, those two things together, is you can have some slight undulation in the liner plate as it goes along. And you dug out the hands and put together. But that rail is going to sit perfectly on grade where it needs to be. So that little bit of undulation that you get as you're digging out, things like that, plus the 18 inches, plenty of space for that carrier pipe to sit in there in a nice way. This picture down here on the bottom is what the spoil bucket would look like. Spoil bucket is pulled out. They have 2 of them. They'll bring one down, put it on the rail. It goes in, they take that out as they pull the second one out, take it out and dump it out. So that's how the material gets in and out of the tunnel. And then after they've done the liner plate, they've put it all in, they're getting ready to put in the FRP or the cast iron, whatever it is. They're going to actually make a form here. And they're going to make this form so that they can, assuming the tunnel itself is being grouted from the carrier pipe to the ID of the tunnel liner plate, they're going to form a nice little bed. So make a nice little cutout to make sure that it matches the grade so that they can make a bed with concrete as they go up. They'll do the same thing as they go through the tunnel to ensure that the OD of the carrier pipe will fit very snugly and perfectly inside of the tunnel liner plate. Is there any questions on that? So this is just what a piece of carrier pipe looks like as it's being stuck inside of the tunnel liner plate as it goes along. As you can see, they have a little bit of bedding over here that they grouted up a little bit, and all this will be grouted in place after they leave. So whenever you decide to go with some tunnel liner plate, some 2-plane tunnel liner plate, you're going to get this sort of drawing from me. I like to just show this so it's something that you've seen before, because again, it can be slightly confusing. We label everything. This is a huge shaft, 240-inch NAD vertical shaft that we get. But you can see up at the top, it says MK1. That would be the first plate that is required. But then you see the 1G. That is a grout core plate, right? So we label all of our plates that go along so the contractor can easily put it all together. And they come from the plant. They're all marked right here on the side of the plate as it sits. MK3, MK1, MK2, 4, whatever. Also in MK1G. They mark all the plates so that it's easy to put together. And this is what the contractor uses as well to install the tunnel liner plate if they're not familiar with the tunnel liner plate, two flange. But as you can see, the various grout plates go along here. There'd be one, it's 12, 3, 6, and 9 are the grout ports on this one, rotating every other one. So it's just kind of confusing, but I just wanted to point out so to make this drawing make a little bit more sense. Any questions on the drawing? So what's needed really to get you an estimate? Not a lot of information. Diameter pipe going inside of the tunnel, the highest height of cover over each section. And that's partly because, as I was talking about with gauging it, if you have a 50-foot deep section, you have a 20-foot deep section, those can be two different gauges, right? So we need to know exactly how deep it's going over each section. And then the type of coating you're wanting, black steel, galvanized. And with that, I can send you a non-signed submittal to look at, an engineer's estimates for your needs, and then specifications if you need something like that to help you out with that. So I said underpass is one of the things that we do with tunnel liner plate, and this is a perfect example of that. I was asked people, has anyone been to Billy's, Montana? Oh, hey, good for you. I've probably done, I don't know, 300 of these, and I've had one person before you two that have been to Billy's, Montana. So way to go. You two? 3. That's great. Y'all ever seen this trick? No. Okay. Just drove through. Just drove through, but you have been to. I get you. So this is a hike and bike trail that we did in Relining, Montana. Goes underneath the interstate there. As you can see, it's a great project. It's a 199-foot long tunnel, 14-foot diameter. That went under the road. The road was completely was open the entire time that they were installing the tunnel liner plate. No disruption to traffic. City also uses this somewhat as if they start to get snow melt, they can also be another way to not go over the road, possibly come through this tunnel. But what I like to show about this specifically is a couple of things. You have the walkway, which you can just route tunnel liner plate if you're using it as an underpass or something like that up to the invert just a little bit without needing any extra submittals or anything extra from me. You can just do a little bit of grout up to that point, spring on, and you don't have to worry about it. The other thing is where the lights are. Run into something like this, we can actually drill holes at specific locations so that you can run electricity through there and put brackets on the liner plates, weld the brackets to the liner plates, so you don't have to mess with that as well. Just make the project nice, easy to use. Lake Texoma, a couple people probably remember the Lake Texoma project, right? This was actually the first project I ever worked on when I came to work at Contech. Really large project from Lake Texoma down to Wiley, 5,407 lineal feet of tunnel liner plate. A lot of different solutions, but 130-inch NAD was what was primarily used by A.R. Daniel and LP Sundance Construction. Delivered unassembled to the job site. Entire project took about a year as far as the tunnel liner plate was concerned. But what I like to show here about this, as I said, this is a hand mining process. This is Bo Davis. He's with A.R. Daniel Construction, and Bo's doing a hand check along the liner plate. So what he'll do is they're digging it out. You dig out too far as you put in the liner plate, you have to spend a lot of extra money on grout, right? Because you have to grout from the outside of the liner plate to the area that you've dug out. So you want to make sure that it's not too big so that you're not spending a lot of money on grout, but you also want to make sure it's not too short, it's not too small, the hole that they dug out, so that grout can get in there and attach itself to the liner plate and the ground on the inside. So they do a hand check very regularly, like 5 times a day as they finally get a tunnel done, just to make sure that they are within specifications. This is Mountain Creek, Fish Creek Interceptor, 2,450 lineal feet of 58-inch NAD, 4 separate runs of 612.5. SJ was construction, LP Sundance was the contractor. I just like to show this one because it makes me glad that I sell liner plate and I don't install it. As you can see, this gentleman sitting right here. Upper Big Fossil Creek was one that just got finished by Circle C last year. A really nice project with the city of Fort Worth. A bunch of different options, but 3,700 feet of 70-inch, as well as vertical shafts. I believe it's 16-foot vertical shafts that Circle C does as well. As you can see, what I was talking about a little bit of how with those oval shapes that we do, sometimes you just have a little extra space that you need on the sides. You can see this is butted up right against this house. It's probably about 3 feet away from it with their nice little retaining wall, retaining fence that they have here. This was on a golf, not on a golf course. This was probably 300 yards from the golf course. And every day they had a bucket of all the golf balls that had been hit into the bottom of this footage. So I went out there one day. We had one as I was taking the drone footage that came right by my head. He's like, it happens every day. So apparently there's a lot of really bad golfers. That's okay. It's fun to.
Maybe they were.
Huh?
Maybe they were.
Maybe they were. Like that's a really big hole. I can get a hole in one there. You know, like that's one I can get. So that was a great project that we did in the city of Fort Worth. So I talked about horizontal tunnels. Now we're going to talk about vertical shafts, vertical tunnels, if you prefer. It's very similar to horizontal tunnels with vertical shafts. There's a couple of big differences. The strength and efficiency, the overlapping seams that you get with tunnel liner plate are still the same. Those things are great. We found that we can, there's caveats to this, but we can accomplish shafts of up to 22 feet without needing to go to readings. That depends on the shaft depth, water table, soils, live loads. Actually, the job that I'm going to show you, we did in Austin, out by the new Amazon fulfillment center. 130 out there was a 25-foot shaft. It was 55 foot deep. It's in that good Texas limestone. So didn't have to worry a lot about the soils on that. But we can accomplish a lot of different things with vertical shafts. Now, ASCE primarily handles the horizontal tunnels that we do. For vertical shafts, they tend to go to the NCSPA or the National the National Corrugated Steel Pipe Association manual. For stiffness factors, if you look up here, see 2 flange, 4 flange, see 33 and 74. Right? I didn't ask you to memorize the ASCE specifications for stiffness for 4 flange and 2 flange. But if we come down here and just do a little bit of math, just times it by 1.5, you get 50 and 111, which is the exact same stiffness requirements that ASCE has. So just to point out why it may be different, it's still the same as far as stiffness is concerned. We're going to get into just some cases to look at here. We'll talk about a couple of different things. So this was a job that was done, the city of Pflugerville, Caramel Sorrento lift station. It had bid like 5 times before they finally went to this company here in concrete and said, hey, we'd really like to have you do this job. It's usually the contractors read sometimes that they thought they gave it plenty of money, started looking at it and realized they didn't. They contacted us. So ring beams for liner plate are extremely difficult to install for first-time users. And that's partly because this ring beam right here has to be pushed outside of the other ring beams about right here. So it's got to be pushed open so that it's flush to the liner plate holding that load back, right? That's what the ring beam job is. Liner plate is sort of there as a superficial area that's holding that back, but it could be if the stiffness allows, it could actually hold it all. But in this instance, they needed to put a ring beam in. So putting ring beams in on a new construction is extremely difficult. So like I said, you have to push the ring beams apart and then they have to come together so that you can bolt them up and they sit snug against the liner plate itself. Having a new contractor install that is sometimes kind of difficult, right? We were on site with Aaron Concrete as they did this. The solution we came up with was 364-inch LED 5-gauge liner plate with 10 by 33, 4 foot by 6 foot beams. So we were on site to kind of help Aaron Concrete as they were working through this process. gave them some tips. You can't really show it. There's a little bobcat here, but they were able to grab one side with their frame, pull that back, and then push the bobcat so that it could open up and then the green beans could slip in. Water was present the entire time they were installing this, as you can see by the boots as well. So part of the issue too that you run into an extremely wet vertical shaft application is water and grout falling down. All right, you've got water, always got to go somewhere. It's going to go to the nearest area to find. So we actually worked with them also on putting straw up inside of the bottoms of this liner plate here, so that when they grout would sit at the bottom of the straw, and when you come out, they didn't lose any extra money, no extra charges or anything like that. Is there any questions about? Yes, sir.
Said for over 20 foot, you need what? So it's 20 foot diameter.
Typically, so 22 feet to need green beans.
Need what?
Green beans,
Oh, so extra reinforcement.
just extra reinforcement on the inside, yes. And again, that depends if you're in pure rock, things like that, water, shaft. This was an extremely wet situation that we had, but Houston, areas like that, definitely you probably might be able to get away with only 18 foot, something like that before you really need to look at things. Any other questions? So this is Palmer Lane in Austin. It's another one that we did. It's right across the street from Apple II. The city of Austin was extremely worried about water being present. And after looking at Caramel Sorrento, seeing how water was present in that, we could understand the point. So they required for the first 10.5 feet of every shaft has to be gasketed. So typical gaskets for many of the liner plates, 4 flange, they will put a gasket all the way around all 4 flanges. For 2 flange, you can't really do that because we have this area here that is connected together. So you can't put a gasket down here through this, otherwise this area here won't come together correctly. So what we do is actually provide just gaskets that they can stick on right here on the face, so they still don't have to worry about any water coming in there. I will say, for our liner plate, if it is bolted correctly to the right PSI required on all sides, you actually don't get a lot of seepage because you have direct face-to-face contact throughout the whole part of the liner plate. Might get a little bit, but not very much. But anyway, the city of Austin was extremely worried about that. So we sent them gaskets. They got through this first shaft, completely dry. So didn't use them after that. But just keep in mind, if gaskets are something you are kind of concerned about, water, things like that in a very soupy area, something that's making it worth it as well. All right, so here's a little video. No comments on my drone skills. I'm not Quentin Tarantino yet. I'm working on it. This is off of Brendan Road, off of I-20 in Dallas. This is a 50-foot shaft that we did for Southland Construction. As you can see, main beams are present the whole time. A couple of things to kind of look at here as it's going on is you can see they are digging it out as they go along with this structure being large enough to have a nice little crane in there. They're a digger that they just pull all that out. There's also guys you can see down there digging as well. Very large shaft. Ring beams that were required. This as well. See the guys working down in the pit there, digging out the sides as they go along.
Well, the whole thing is being built and sliding down as they go.
Yes, sir. It's built from the top down. Yes, sir.
Those are, I guess, some blocks holding it up.
No, those were actually just liner plates that they had kind of put there so that they knew the right place to put them when they were going to bag spot. And this is that shaft that I was talking about. That's 25-foot wide shaft, 55 feet deep. outside of Pflugerville, the Amazon Procurement Center. They have there. I had this cool idea. I was gonna like fly down and go into the tunnel, and it was super, super windy that day. And you'll see that chicken out. I didn't. It's a company drone, right? So you can't destroy company property. But this one actually had a sister tunnel that was about 300 feet away. They were connected to the same size, same everything along. So any questions on vertical shafts? It is tough. It is tough to do things like that. A lot of times, if they can, they will, as they start that first line, they might go 3 or 4 plate rings together to try to get a nice start point. As they dig it out much larger than it has to be, so that they can stick that in. And then, if possible, they may throw some water to see if they can make it a little soupier, a little waterier, so that it may hold it back a little bit. But it is a much more challenging process to install it as it goes along. I don't actually sell a large amount of liner plate in the sugar sand. I think just because it is such a time-consuming process, but it can be done. We did a West Harris County job that actually required that, and that shaft alone took 9 weeks to install. It's a very, very intensive process. Any other questions? All right, relines. So this is something that they do a whole lot up north. We sell liner plate up north for mostly relines, not the new application construction. Because they have extremely old infrastructure, they would rather just see if they can fix it, putting a reline in as opposed to tearing it out and replacing it. We've had a reline here in Texas, in El Paso, at the University Park ballpark. It's where the El Paso Chihuahuas play. There was an existing line, a concrete line that was right here, that they put the stand kind of over the top of. I don't know if they just missed it as they were installing it and didn't think about it being that close. They were starting to have some RCP cracking and some joint movement, as you can see as well. So they needed to come up with something to fix it. So we came up with using tunnel liner plate. 74-inch tunnel liner plate inside of an 84-inch, 82-inch RCP. As you can see, the guys were able to stand up in here as they were going along and build the tunnel liner plate. This is a manhole. You can't quite see it. I'm going to take a good picture right here. So they were taking the tunnel liner plate stacks and dropping them down inside of the manhole so they could just work out of that. 637 feet to replace that 84-inch RCP. It was actually, after it is put in, all the liner plate is built up 637 feet, 65 feet a day. In my world, if you're installing tunnel liner plate and you're getting 10 feet a day, you're like the Mick Jagger of installing tunnel liner plate. So to see 65 feet a day where you're not having to dig, it's really, really cool, right? These guys were really going fast. But after they installed it all, then they had to grout. They had to grout the liner plate to the inside of the RCP. So the RCP now all the weight shifted to the tunnel liner plate. So we're handling the full load with our tunnel liner plate. But a great project that we worked on. Would love to have another one. I got one with Dallas, City of Dallas, so we're starting to work on a little bit as well. So if you guys run into something that, please let me know. Any questions on relining? So grouting, I've talked a little bit about grouting right as we go along. Grouting is an extremely important process to this tunnel liner plate. It has to be grouted, has to be. We'll put grout ports in there in the liner plate for you, but it has to be grouted so that the connection to the ground liner plate is made correctly. Now, some of the stuff I will tell you with grout ports that we do, I typically, and this is just something that I've done over the 14 years that I've been at this. We have, say, 48-inch NAD liner plate. So I'll say I need a grout port, one grout port with 3 rings. You're in some bad soils, you're in some super soils, a little more concerned about that. We can change that to grout work everywhere. As I get larger, so if it goes to 90 inches, I'll go to a grout work every other week. As we get into the 100, 112 area, those are the grout work elements. Just to make sure that the contractor, they run into an issue of ground where they're really concerned about it, they have that ability to grout the line. Yes, sir.
Just to give a bit of noise.
Oh,
What's the reason that you're talking about doing the troubles?
yeah, I mean, it's important to do it every day, if you want.
So
but-
what frequency were the,
Oh. Yeah, so if you get to about 100 inches, you probably want to grout fork every week, just so that if you run into that situation where maybe it's, the ground is really bad, maybe very soupy, something like that, that you run into, you can grout immediately as you need to help make sure that there's no problems with the tunnel liner plate or the tunnel that you had.
And the grout ports are at the top.
They are, yes. So they're usually, there's one at 10, one at 12, and one at 2. So 10, 12, and 2. And like I said, we will rotate those.
Not 10, 2, and 4.
Not 10, 2, and 4. No, that'd be easy. Come on, yeah, no. 10, 12, and 2. Sounds cool, yeah. But yeah, 10, 12, and 2, and then we'll rotate them one every 3 weeks. Obviously, the first plate is always a 12. So you want that first one right there, where the grout can go off. Then it'll rotate. Now, for the vertical shafts, we go 12, 3, 6, and 9, all the way. To make sure, because they're much larger structures, make sure they have plenty of air to grout on it. And as I said before, the grout will actually fall down. So you got to make sure you get the coverage. So grouting is extremely important. And the one thing I will say too about the placement of the grout port, if you're like Buzz, I need it at 2 and 4, we can put it at 2 and 4. If you need it at a specific spot, we can do that as well. Happy to do it. That's just kind of typically what we do is 10, 12, and 2. The other thing I will say we run into a lot is frequency of grouting. And I would almost kind of say it's not really our place to say how often you should grout, right? Because cities have specifications of things they want. I will say, if you have 10 to 12 feet, if you got that in, that should definitely be grouted. But if you're in solid rock, like limestone, like in San Antonio, and you're getting 6 inches a day, you can't even grout, right? Because each plate is 18 inches wide. So typically, whenever you get a couple number of plates in, you have something to grout back to, so that the grout has something to connect to. If you're grouting after every plate, that's a large amount of frequency. You're not getting a lot of tunnel footage as you're going along, right? So typical 10, 12 feet a day should definitely keep grouting. Has to be. Now, I've been the problem because I never really thought about shifts until recently, right? I'd always said, hey, grout after every shift. And, well, I never placed it in my brain that sometimes they're running 4 shifts a day, 3 shifts a day, so at the end of every shift, they're having a grout because of that. So sort of move that to just something at the end of the day. It needs to make sure it's grouted. Just because that way they can get some footage, install some production, and move along so that your project actually moves it. Does that make sense? Yeah. Any questions on grouting?
Is it a specialty grout or is it a common grout?
Yeah, it's just a common, it's not a what's the thin, a nice heavy grout, a flowable heavy grout. It's not the cellular grout, that's what I was saying. Not cellular. More flowable grout. All right. So that's the end of that, Stronger, lighter, safer construction. As you can see, these guys, it's an old picture of them digging it out. When you can't open cut, larger diameters of shafts and lines, special shapes and sizes, and tunnels that, we didn't talk about it, but the tunnels that change directions.